Now starting with the next problem on pyramid, which is the second problem for hexagonal pyramid. So hexagonal pyramid 25 mm side of base and 55 mm long axis is resting on one of its triangular faces on the HP. Draw the projections of the pyramid when its base edge is in the HP and is inclined at 45 degree to the VP. Now, if this statement is also not given, base edge is in the HP, for keeping one of its triangular face on the HP, in first stage we need to keep the entire base in the HP with one of its base edge on the right hand side, as done in the seventh problem. So first stage will be same as the seventh problem, only dimensions are different. So we need to draw the hexagonal base below xy line with the two sides of the hexagon perpendicular to xy. Okay. So we start with the first stage. Top view will be a hexagon with two sides of the bases perpendicular to xy line. And since it is a three-stage problem, you need to decide the space utilization. So first, now since it is hexagon, we can directly use circle method. With the help of vertical diameter, we will do the divisions to get hexagon. So here 20 side of the base is 25 mm. So we'll draw the circle of radius 25 mm by keeping some distance below xy line. Mark the center. Then first draw the vertical diameter, because we want two edges perpendicular to xy. So we'll divide the arcs with respect to vertical diameter, so that automatically we will get two edges. So cut the two arcs with two end points of the vertical diameter. And if we want two edges parallel to xy line, then we should use horizontal diameter for dividing the arcs. So we'll make the entire hexagonal base dark. So obviously we are getting two edges perpendicular to xy. Now in addition to the hexagonal base, we'll also show the slant edges by joining with the center of the circle, which is nothing but the apex. So we'll just produce all the diagonals to get the slant edges. Then we'll give the numbering. We can start numbering from anywhere. Then go center of the base and apex. We will complete the corresponding front view. For that, first we will mark the axis, which is given as 55 mm. So first on this line, I will mark the axis of 55 mm. Here. Then we'll project from other corners up to xy line only. No need to project up to 55 mm, because we are getting a triangle as a front view, not as a rectangle. So we can produce other corners up to xy line only. Then 1 and 6. Be careful while drawing the parallel lines. Okay. I will mark the corresponding points 3 dash 4 dash 2 dash 5 dash and 1 dash 6 dash. I will complete the triangle in front view by joining the slant edges. Now the base and then slant edge from 2 and 5 will be visible. That will coincide with slant edge from 5 also, which is hidden, but preference will be given to dark edge, and also axis will coincide here. So we'll show O dash also. So this completes the first stage. Now in second stage, we need to keep the triangular face on the HP. Okay. Now triangular face here is 3 dash 4 dash O dash. This slant that inclined line in front view is nothing but the triangular face. So we will make this line entirely coinciding with XY line, so that the triangular face lies on the HP. So for that, the condition is this base edge should be on the HP. So I'll fix that 3 dash 4 dash here, and then we will mark the length up to apex, that is the length of the triangular surface. So this inclined line is nothing but a triangular surface. So we are coinciding with XY such that the triangular surface is on the HP. So this will become O dash. Now we'll complete the triangle by marking the 2 arcs, this one, and from O dash 1 dash 6 dash. We need to just produce this more. We'll complete the triangle first. We'll make it dark. Now the base has shifted to this position, so we'll mark the center division 2 dash 5 dash O dash from any one of the corner. That is again dark. This is 2 dash 5 dash O dash. O dash is again marked, so 1 dash and 6 dash. I will complete the corresponding top view in second stage. Apex. Corresponding projectors from top view to second stage. Again here 2 points will coincide, 4 and 6. Again from the center of the base. Again from 1 and 3, and then last is 2. So we'll mark the corresponding points 4 and 3, 2 and 5, then O, center of the base, then 1 and 6, and then again apex. So observer position is this. First condition for visibility, boundary dark. So we'll mark the boundary dark first. Whatever edges lying on the boundary will be dark. Then among the slant edges, O5 is on the boundary. Then O2 is on the boundary. For the observer, for the observer, 1 dash among the slant edges, 1 dash 2 O dash 6 dash 2 O dash is nearer to the observer. So those slant edges will be visible. So I'll mark 1 O and 6 O dark. Okay. Now we are left with three base edges, 1 2 2 6 1 2 1 6 and 1 5. Since the entire base is visible to the observer from this direction, so we'll make the remaining 3 edges of the base also dark, because the entire base is visible to the observer. So this finishes the base edges. Now we'll move to the remaining slant edges, which are O4 and O3. Okay, O4 and O3 is the triangular face is on the HP, so it is the farthest from the observer. So both the slant edges from 3 and 4 will be hidden. So we'll draw dotted lines. From 3 and 4. Okay. Just check once again. Now we are left with the axis. So OO, long dash, short dash. Many times we forget to mark the axis. That is also important. Now in the last stage, we need to redraw this top view. But now the condition for redrawing the top view is given as Draw the projection of pyramid when the base edge is in the HP. So that condition is already satisfied by keeping this 3 dash 4 dash in the XY line, on the XY line, and is inclined at 45 degree to the VP. So this 45 degree inclination to the VP, which will be used for redrawing this top view, because for top view we need condition with the VP, which is given as 45 degree for the base edge, which was kept in HP. So that base edge in the top view I am getting as 3, 4, and it is the true length, because whatever is the length of 3 and 4 in the first stage, same length is being carry forwarded in second stage. So it is the true length and true inclination. So I can directly redraw this by making 3, 4 inclined at 45 degrees. So no need to mark the apparent angle here. So we'll again follow the rectangle method. We'll first enclose it in the rectangle, and again before rotating we need to check the condition for apex, whether it is nearer or away from, if it is given in the problem. Nothing is mentioned like this about the apex, whether it is nearer to the observer or away from the observer. So we can tilt in any direction. So better we will tilt in this direction, so O is nearer to the observer. So for that we need to make this edge 3, 4 inclined at 30 degree. So we will make this boundary inclined at 30 degree. So obviously 3 and 4 will become sorry, not 30 degree, 45 degree. So we'll first mark the angle of 45 degrees. And we'll tilt like this so that apex will come nearer to the observer. So on this, we'll first mark this edge of the rectangle. So this point will mark here, so nothing will come above that. So this is one of the edge boundary of the rectangle. Now we'll draw the perpendiculars from each point to mark the two other sides of the rectangle by directly using the set square. No need to waste your time using the protractor and marking 90 degree. Okay, so after drawing these two perpendiculars, I'll mark these two lengths of the rectangle, which will be same. So we will cut two arcs to mark the length of the rectangle. Then we will complete the rectangle. This rectangle should be light. Now, with the help of this rectangle, we will draw the remaining corners. That means for marking 4, I have to take this distance, which will be same distance for 3 from the opposite corner of the rectangle. So 4 and 3 will get by same distance. So for marking 4, I will measure from this corner. For marking 3, I will measure from this corner. So this is 4 and then this is 3. Then for marking this OO, it is obviously center of the rectangle. So we'll take that distance. So I'll mark that line and we'll draw a parallel line that will give me the center line for the rectangle on which OO will lie. So obviously this end will be the apex O nearer to the observer, and for marking O, I'll take this distance, which is the base. Then for 5, I'll take 5 and 2. We will take this distance along the length of the rectangle from the same corner. So we will mark this will give me 5 and this will give me 2. So this is 5, this is 2. Then for 1 and 6, we'll follow the usual method. We'll first mark the parallel distance for 1 and 6. Then draw a parallel line to the boundary of the rectangle. And from the center line, we need to take the corresponding distances, which will be same for 1 as well as 6. So this distance we will take for 1 as well as 6. Some error is acceptable. So this arc will give me 6, and with the same distance on opposite side will give me 1. So now we have marked all the 6 points of the base. Now we can join with the same visibility. So first boundary arc 2, 3, 3, 4, 4, 5, then O5, then O2, then entire base is dark 1, 6, 1, 2 and 5, 6. Then slant edges O6 and O1 are dark. And remaining two slant edges 3, 4, O3 and O4 are dotted. So we'll redraw with the same visibility. And then we'll draw the axis at the end, long dash, short dash. Okay. Now this is satisfying the condition. Base is inclined at 45 degree. So we'll show that angle phi 45 degree. Now we'll complete the final view by projecting from both the views. So 2, then 3, then 1, 4, 4, 6, 5 and again apex. Similarly, we'll project from front view starting with XY, then 2 dash, 5 dash, O dash, and then 1 dash, 6 dash. Now we'll locate the points. First 2 dash and 3 dash will be on the XY line, then 1 dash will be on the topmost line, 4 dash again on the XY line, center of the base here O dash, 6 topmost line 6 dash, 5 along the same line of as that of 2 dash, then O will be again on the XY line 2 dash. Okay. Now observer direction is this. So first rule of marking the lines is boundary arc. So 2 dash, 3 dash, 1 dash, 2 dash, 1 dash, 6 dash lying on the boundary. Then with the apex we are getting 3 dash, 4 dash as well as 2 slant edges, that is O dash, 3 dash, O dash, 4 dash. So here on the same line we are getting 3 edges, one base edge 3 dash, 4 dash, then 2 slant edges O dash, 3 dash and O dash, 4 dash. So that should be dark because it is on the boundary. Then O dash, 6 dash, the slant edge is again a boundary. So we have marked the boundary dark. Now we'll move to remaining edges, which is 4 dash, 5 dash and 5 dash, 6 dash. So if you see the observer position, phi is the farthest point for the observer. So all the lines passing through phi dash should be initially dotted. Then we'll see if any line is lying on the boundary, then it should be made dark. But if you see this edge 5 dash, 6 dash is not lying on the boundary, again this edge 4 dash, 5 dash not lying on the boundary, then slant edge 1 dash, O dash, 5 dash again not lying on the boundary. So this will be kept as dotted only. Now we are left with only 2 slant edges, which are 1 dash, O dash and 2 dash, O dash. If you see observer direction, O2 and O1 are nearer to the observer, so those slant edges will be dark. So O dash, 2 dash and O dash, 1 dash will be dark lines. Then at the end we need to mark the axis O dash, with long dash, short dash. Okay. See once again, all 6 edges, base edges are marked, all 6 slant edges, though I can see here only 1, 2, 3, 4 and 5, but here 2 slant edges are coinciding. Okay. So now we'll complete after marking the dimensions. So the base edge is 25 mm. Next axis height is 55 mm. Then triangular surface lying on the HP, no need to mark the angle there. Then here phi is already marked, which is 45 degrees. So this completes the solution for this particular problem.